Hey everyone, it's Vlad. In today's tutorial I'm going to show you how to create this animation. Let's take a look. Great, enough. Before jumping to the software, let's establish some things. What we're going to do now, we're going to create a line, then we're going to copy the line like here 6 times, and the line will have a certain amount of points that will be rotated with a bit of an offset. That will create this kind of a spiral shape here, and then we need to drive the points along the paths here, along these curved paths. When we do that, we will set up a normal vector for the leaves, because we need them to be pointed in certain directions. So let's jump into the software. Okay, let's create a line here from the shelf tool. Cool. Let's call it Aloe. And now what I'm going to do, I'm going to set the length of 12, number of points 24. The direction will be X. Cool, visualize points here. Now we need to set up this offset attribute for the points. I'm gonna call it ramp, and what we need to do is divide the actual point number by the number of points on the line. It's going to create for us a ramp attribute, kind of a multiplier for rotation, so it's from 0 to 1. Cool. We also need a up vector. Vector. The vector, the points will be rotated around. Let's copy these lines. Total number of 6. 360 divided by copy parameter, and then paste relative references by 6. In our case, give me a second. Okay. Too much Ctrl Z. Let's do it again. 360 divided by total number of copies. Cool. Now we need a new attribute wrangle node. This wrangle is used for rotating the points. First thing is to create a vector for quad variable. Here we need to call a quaternion function and set some values here. First attribute is ramp, the amount, the angle, and the vector up. So we will be rotating around up vector this angle ramp. Nothing happens because we need to basically apply this quaternion to the p vector, our position. So I type qrotate, type here our quaternion, and rotate our p by this quaternion. Now we have this kind of curved lines, and I would like actually multiply here by 6. We can create a channel F that will help us, we call it mul, like multiplier. It's a bit more convenient. Let's choose 6. Cool. Next step is to create a VAP node, point VAP. Right. Now we need to drive the points along the path. Yeah. So we need to drive the points. But now we have points and primitives. So we need to get rid of the primitives with add node, delete geometry, but keep points. Now we have only points, and we append this attribute wrangle node to our attribute WAP, the second input. Yeah, and what we need to do here, add some nodes like x, y, and z distance, and like a primitive attribute. All right, we have it, and our inputs, a second, be like here, connected, position for x, y, and dist p, and these nodes like usually work together like really good. If you don't have this node, you need to set up this primuv attribute yourself. That is pretty actually easy, but here it's more convenient. We need a vector to float. Give a second, vector to float node. And to give us primuv here on u. The vector. What about the vector? We need our attribute p. Yeah, cool. So next thing is to connect it with p, and we have this because we didn't specify our primitive, and I need our primitive to be specified, so I just connect it like that. Now it works perfectly. What we did here is we took some values like primuv, like prim, and what it says, it gives basically an attribute for each point here. Primuv, it says where this, for example, point is located on the path that we had, like on this path, where this point is located. And you attribute it usually like from 0 to 1 here, like that. And when you specify this u attribute for primuv, you will have a position. So we take these values prim and primuv, so we can have our points stuck like in the same position as it was previously here. It works not perfectly, but what we can do now is we can move the points along the paths from that go from the second input here. So when we add our u attribute with time, and important step is to add a modulo. Modulo is, I can explain. You can imagine modulo as this kind of step function. I don't know where good representation here. When you say we like our divisor is 1, we'll basically delete our input values. We kinda divide our values by this divisor, and if we choose 1, we will have kind of a loop from 0 to 1. So we will have from 0 to 1 values, and then it's gonna repeat when our float, this values that we have here, u, goes above 0. It's gonna be anyway give us like it's gonna be 2 or 1.5, and it's gonna anyway give us this 0.5 value. It's actually kind of a loop. Not the best explanation, but you can check on the internet. Alright, next thing is to divide our time by a constant, because now it's pretty fast. You can see it kind of works, but it's moving now so fast that it creates this movement inside, from outside to inside, but it actually moving from inside to outside. I will preview this because we need to divide it, for example, by 20, and now we have our points moving this direction. Great. And the next important step is to add another XYZ distance node. Let's copy this. And our new position will be gone from here. Cool. We need also by an export node. And we take a premuv, yeah? I need a vector to float node, cool. Connect it here and connect it here. We call this attribute u. And now we have a dynamic u attribute. That means when the points move, each frame, their attribute u is being updated, and we'll basically have the value that says where this point is located, in sense of on this kind of a primitive here. So to explain differently, it's kind of, we have this primitive, it has u from 0 to 1, and when the point moves, you can always its value is being updated, and we know where it's placed on the primitive, in the beginning, in the end, or in the middle of this spiral primitive. And it actually, each one is a primitive. If you visualize it, you see it's 2, 3, 0. If you want them to be, of course, different primitives, because they can be different primitives, we can add convert line node, and you will have them as different separated primitives. But you can do this kind of a setup with this approach, I think. Yeah, that's pretty it for this part. And now what I need to do is add another attribute, triangle node. We have our points like located, yeah, we have our points moving, and what we need now is to set up some vectors that will help to point them in desired directions. Let's do it now. Let's create normal. Let's create a side. Yeah. By the way, let's first of all visualize stuff. It's going to be marker. Okay, our normal will be, I think, let's do it like blue vector. Cool. We also need vector side. Yeah, side is going to be like red. And also up vector like green. Cool. We have it now. We can't see anything because we don't have like actual computed vectors. Okay, we need to like set some values here on our normal, and it's gonna work like that. We are going to use our P position as normals. See, I want to invert them towards our center, and of course I want to normalize them because normals must be normalized, because we are going to use it for our directions to orient our leaves. And the next thing is to create a side attribute, and a side attribute is really a cross product of these two vectors. So what I do now, I call function cross and type here up vector and normal vector. Boom. Now we have our side, but don't forget to specify that this is a vector attribute. So now it works. Cool. Why did we do that? Because we need our normals. These normals. By the way, I need them to be blue. Yeah, we need to rotate them around this vector. This red is our side. I'm gonna use matrices for this kind of operation. I don't know why I see this visualization of line. Strange. Okay, doesn't matter. Let's create a matrix. Yeah, I need type here matrix 3. Like that type, and M is gonna be our name for the rotation matrix. We're gonna call the function ident. So we have ident matrix 3, and then we need to rotate the matrix. Let's do it. We need to use rotate function, void function. We don't save any values in some variables here. We just do rotation for the matrix, like here. Then I need some amount here, and I need the vector we will be rotating the normal around. Okay, that's our side. Yeah, but we don't have amount. I also create an amount. That's the angle. It's going to be a float variable. Let's call it amount. And now I need to say that the amount will be defined by the length of our P attribute here, multiplied by some kind of a channel I will call rot multiplier. Yeah, great. Boom, done. Now we have our slider. nothing happens here because we need to apply the vector to the matrix. We need to multiply the vector to the matrix, multiply by the matrix. Okay, let's do it. Our vector is normal, right? And what I do now is multiply equals that means, you know, this a equals a plus b is really the same as a plus equals to b. So I type here and multiply by matrix. Boom. Cool. And I copy that and multiply our up too. Looks like a mess, isn't it? So here we go. Here our rotation multiplier vector, not vector, the channel. And this channel helps us to lower the values a bit. Yeah, and it's now it's like being rotated downwards, and now I need to invert, say minus channel, basically multiplied by 1 by minus 1, and now we have something like that. I think this value would be pretty good. Okay, our vectors are like done. And now it's the part for setting up p-scale and copy our leaves on the points. First of all, I think let's add a copy stamp node. Here we go, our file. Nice. In this shot I just used a already modeled leaf. We don't need to model it now. Lots of points. Let's turn off this visualization, and I'm gonna append a transform node for the leaves, and I'm gonna scale them up like a bit. Here we go. A bit. Yeah, now we have something like that. I think 75 would be good, or even 50. Also depends. 50 is good. 25. 25. See gaps. 35. That's great. Cool. And in addition, we need to back geometry, check this box, back geometry before copying. So the leaves copied now are much lighter. They are not so heavy, and the animation will be pretty smooth. Now it looks cool, but yeah, we need to do some stuff. And by the way, let's play with this rotation multiplier. I would like to set it this value because it was too much. Okay, now it's moving, and the next important step is to set our p-scale attribute, and we use the wrangle node for that. P-scale will be based on our hue attribute that was created before here. Basically, it's been updated every frame. Yeah, and we, like every frame, we know where the point is placed on the primitive. So we can say in the beginning, it's going to be 0. In somewhere in the middle of its way, it's going to be maximum. It's going to have maximum p-scale, and in the end, it's going to have also 0. We need for that channel ramp, call it ramp, no, call it p-scale, based on our U attribute here. And now what I do, I draw this kind of a curve here, b-spline time, b-spline, b-spline, cool, 0, 5, and now I have that. And you see we immediately got some results here. The p-scale attribute was transferred on the leaves. And now we have this kind of a cool transition from 0 to 1 and then to 0. And you can play with it and control it any way you want, how you want. And now you see we have these gaps. That's because we need a bit higher value here, like that. Wow, it's pretty cool. It's also like bend a bit. We can add another, not another, but new bend node, and help it to deal with it. Bend. Let's set capture direction as Y, and up vector is gonna be -1 with Z. Z direction. Capture length is gonna be like 10. No, not 10, like 50 or something. And 50 too much. 35. 40. Okay, 40 is good. And now we can bend it. Let's bend other way. Like that. Now it's pretty straight. Yeah, you see. Yeah, of course, you can use this U attribute to control even your bend. And it works like that. You call it bend, you call it here bend, you add a new channel here, channel ramp. What we're gonna do from 0 to 1, perhaps something like that, I don't know, we'll see. Let's leave it by default. And now what I need to do is check this stamp inputs checkbox, and we need to stamp bend attribute. Okay, we have it, and we need to type a little expression here that will be like stamp brackets, go a level lower, and specify our copy to node. Cool. Then in brackets, bend here, and default the values, and some value when this function doesn't find any this attribute, doesn't find this attribute, it's just set this bend value by 0. We can choose 1, 45, it's up to us, but let's do it like this. Cool. Yeah, you can't see anything because we have our bend from 0 to 1. Logically, we need to fit our values from 0 to 1. For bend, it's not enough. We need values like 45, 80. So we need to do some kind of a fit. 0 to 1 to from 0 to 45. We'll see how it looks. Yeah, it's pretty good. It's from, I need to change here a bit, like that. Cool. Here a bit straight. Here a bit straight. Yeah, and now we have this shape I wanted. Looks pretty cool, I think. Perhaps I need some B-spline shape here. Yeah, you can also play with it. You can also play with B-scale. Have some interesting results. Also play with these leaves forms. Also can give some cool results. You have a line here, and that line, we have a copy node here. You can control the number of lines. Yeah, we can have some different scales here. I don't know, we can play with it. I came up with some pretty cool and unusual results when I played with it. So that's pretty it. Now what about colors? The colors. Let's create a color node. Yeah, and then we need to change the color over time. We will use a solver for that purpose. Okay, color, cool. Class point, constant color. Yeah, we can't see any color here because we need to get rid of our previous attribute on the leaves. Remove attributes, remove groups. Now we have our white color. And let's choose red or green. I don't know, we can't see anything because something bad happens because we need to use template point attributes to transfer these attributes here. Okay, great. Let's red, yellow, I don't know. Okay, let's have this yellow color. Yeah, how do we change this yellow color from inside out and stuff? For that reason, we use solver, subsolver. Important step. We do this pin following selection. Go inside. Let's place it some. Okay. Create a new attribute wrangle node for our previous frame. We will be copying the colors, the color attribute from our previous frame to our count frame. We need from previous frame to our current frame and current animation. Now we have moving leaves. Cool. And now we're gonna dive in. Let's do it if some basic expressions, time divided by time increment is bigger or equals to 24. Yeah, let's leave it like this for now. We gonna set our CD channel vector. We call it color. Yeah, got it. We don't click this button because I need some interface, additional interface here, additional channel. Yeah, this type channel. And I was a bit rushy. I need to name the label and then name like color. Now click this button and this channel like refers to this controller. Cool. Okay, now we see that we change in colors like instantly here, like to white. Let's choose some other color, yellow. No, not yellow. We already have yellow. Green, reds, green, green, green. Let's green. Let's have green. Now we have our colors changing instantly. Ah, what the fuck. white. Why do we have white? No, this is pretty strange. I don't like it. Something is wrong here. Something is wrong. Let's see. Yeah. We don't need match p attribute. I forgot about this. We only need to transfer our city attribute. And now we have on our 25th frame, we have our color changed. Cool. Yeah, but it's not what we want. We need to these values being set like here when the point starts to move from the beginning of the primitive. Yeah, and okay, we use this our u attribute to specify when our if condition will be working, and it's gonna work when time is equals when our frame equals or more than 24, and important that 2 of the conditions are true. Yeah, and our u should be true, and we say that u must be lower than this value here. Yeah, and I think this value is good because when they appear in here, they have u value almost equal to this one, like lower. Yeah, and now they should accept this color there, you see, and now they are green. Yeah, it works like that. Yeah, looks like we only have like 20 nodes or something. It's pretty simple. When I created it first, I had a lot more nodes because I was experimenting, and like yesterday I did kind of a resetup and made this setup much simpler than it was before and much shorter. So it's kind of good practice to get back to your setups and see what you can improve there, what you did wrong and stuff. So I hope this lesson was helpful. You will have the original file, so you can see how it was created. You can also play with it, and I hope you enjoyed the lesson and the tutorial. Thank you for watching. Goodbye.